Hi everyone, and welcome to my first video. And this series will be on transition metal chemistry, but I just wanted to do a few of them, reviewing some of the concepts of atomic structure that are going to be helpful for us in understanding the complex chemistries of the D and the P block elements. Um, so in these videos, we're going to talk about the very basic concept of atomic structure. We're going to talk about things like the orbitals and the quantum numbers and so on. I'm not going to get into the tiny details of every concept. For instance, I'm not going to go over Planck's quantum theory or the Heisenberg's uncertainty principle. All that stuff is for first year chemistry course, so if you're looking for details of those concepts, this series is not the right one for you. This is just brushing up on the concepts that we learned in first year chemistry, so then we're on the same page when we discuss transition metal chemistry. So in this video, we're going to start off discussing the very basic concept of an orbital. What is an orbital? And my mouse just stopped working, but there we go. So an orbital, first of all, it's not the same as an orbit. There are two different words with two different meanings. An orbital is really just that three-dimensional space around the nucleus where the probability of finding the electron is maximum. Probability of finding an electron is max. So it's just a 3D region around the nucleus. So we all know that an atom consists of a nucleus and there's all these electrons around it. Remember that electrons are not static. They are moving around the nucleus, and that is why we have this concept of orbital, that it is just a region of space around the nucleus where at any particular instant you can find chance of finding an electron are the highest, are the maximum. That would be an orbital. Now we know there are different types of orbitals. From high school chemistry, we have the sp and the sp D, and the F orbitals. Now they get these letters, which is a very common question that is asked, but not a lot of textbooks discuss that. This comes from sharp, S comes from sharp, P comes from principal, D comes from diffuse, and the letter F comes from fundamental. Now where are these names coming from? These names are coming from the names that were formerly given to the spectral lines that were observed when they were doing these experiments on the atomic spectra. So that's where these names are coming from. Not often we ask on an exam or anything like that, but just out of curiosity, if you wanted to know, that's where the letters come from. So, having said that, I would also like to mention a few other things about orbitals. An orbital can only contain a mass of two electrons with opposite spins. Now, I'm sure you have a vague idea of what I mean by opposite spins, since hopefully most of you have taken high school and first year chem already. But the maximum of two electrons is the most important, is the take-home message here. An orbital can contain either zero electrons, so it can have no electrons at all. It can have one electron, or it can have two electrons. And this is usually denoted in writing like this. So we have an orbital in a square, just a writing notation, and then an electron for some reason is denoted by an arrow like that, and then a downward arrow would mean that the other electron is of the opposite spin. Another way of noting is just drawing full arrows rather than half. They're both equivalent structures, and there's really no difference between the two. So opposite spins and two electrons is the max for an orbital. We're going to continue this in the next video.